So what we have here is the 5 different kinds of sampling that we're going to discuss. Yeah, I think that is probably better. The first type of sampling is going to be random, and random samples are what we really want to have. That's actually our best kind of sampling because they're what are called probability samples, which means that the rules of probability apply to results taken from this kind of samples. A systematic sample is also a fairly random sample, as long as you're careful about choosing the parameters that you need for that sample. A convenient sample is exactly what it says that it is. It's a sample that's easy and convenient to take. If I had a question that I was interested in finding out what students think about some issue of the day, I could ask just this class, because conveniently you're here and I can ask you, you're all students. But the problem with that kind of sample is that you're not a representative sample of the whole entire population of Northeast State, so that would be a problem. If I was trying to determine what college students in general thought, that would be a bigger problem, because you have characteristics that are common to the people in this room and may have some commonalities with the population of Northeast State, but maybe not, for example, the students at Memphis State or at Caltech or MIT. You know, we all have different demographics. So even though it's convenient to ask you that question, the information that you'll give me, regardless of how honestly you answer me, isn't going to be very worthwhile. Then we're going to talk about stratified and cluster samples, and they're listed last and listed together because they have some commonalities that if we aren't careful in learning how to take those, you're going to be confused about which is which. So we'll begin here. By talking about random sampling. Random sampling basically says that the selection of the units, and it may be people, it may be petri dishes, it just depends on what we're collecting, but units will all have an equal chance of being included in the sample, which would be another reason why this class by itself wouldn't be a random sample of college students at Northeast State, because not everybody would have a chance to be chosen. You were chosen just because you were in my class, so that's not random. It takes either a computer or a calculator with some kind of a routine built into it, programmed into it, to make us able to take a random sample. You can't take a random sample without some kind of device to help you do it. Because as unbiased as we might try to be in statistics, when we make our choices of sampling units, if we make it based on just whatever we think is going to be representative, what's going to happen is our own biases are going to come out, whether we intended it to or not, and the sample that we get isn't going to be a good sample. So we'll talk about a way we can take random samples. Systematic sampling says that you pick some random starting point in your population, and then you count every so many members after that, and the ones here, I randomly chose the third person in line, and then chose the third person after that every time. So I had a system for doing that. It's the same thing as what I call file cabinet sampling. If I had a whole vault full of file cabinets with student records in there, and I needed to sample, let's say, 200 or 300 records, then I would randomly choose, by numbering the filing cabinets, and randomly choose one of the filing cabinets, and then again randomly choose a drawer. Assuming that there's 4 drawers, I would randomly choose one of the 4 drawers, and then just, like reach in the filing cabinet to get the first file, but then maybe count every 100th file after that, or every 300th file after that, until I got as many as I needed for my sample. Convenient sampling is just simply sampling results that are easy to get. You know, you can hang out your one and ask the person on the street. Chances are he's not even going to answer if he doesn't have strong feelings one way or the other about the question. Stratified sampling means that you subdivide your population into different groups. For example, here we've chosen men and women. You could also choose freshmen and sophomores if you're talking about people in community colleges. Or you could talk about 5th graders, 6th graders, 7th graders, and 8th graders if you're talking about middle school. So you have a naturally occurring group, and then you select some from each one of those groups. Here we're choosing 3 out of the group of women and 3 out of the group of men. Cluster sampling sounds similar because cluster sampling says that you divide your population into subsets, which we call clusters, and randomly select some of those clusters. So the key difference between stratified and cluster sampling is while both of them involve grouping your population in some way, in stratified you take some, so stratified some from all. Cluster is you take all of some clusters. You take all that's in certain subgroups. Now, in order for you to understand how to do that best, we'll come back to this at the end of the lesson and see if we know how to do that. But to get started here, you have a handout, which hopefully you got printed before class, where we're going to talk about the different kinds of samples and actually take those different kinds of samples. Before we get started, I want everybody to get the calculator that you're going to use in this class. And if you plan on using the TI-83 that's on your desktop, at least when you're allowed to, then go ahead and do this with this one too. Either your handheld calculator, your calculator on your iPad, whatever calculator you've got, and once again, keep in mind, you can't use the one on your iPad or your phone or the computer on test day. You have to have a handheld TI-83 calculator or TI-84 calculator. But in order to make sure that our program functions correctly on the calculator, what I want you to do is turn your calculator on and clear off whatever's there. And I want you to type in the last 4 digits of your phone number. Not the whole phone number, just the last 4 digits. Okay? And then I want you to click the button next to the number 1 button down here where it says STO. So the first column of keys next to the last button. I want you to click that STO button. And what should pop up is an arrow that points to the right. So we're going to store this number that you've typed into your calculator, and we're going to store it in the random number generator. So we're going to press the math button and go over to the PRB menu and hit enter. So I've typed in my cell phone, the last 4 digits of my cell phone number, and I'm going to store that number in the random number generator. And what that's going to do is called seeding the calculator program to begin at that number. That way mine's beginning at a different point from all of yours. And then what the calculator does after that to choose random numbers is it somehow has a formula built into it that lets it pick different increments every time, and it'll start at my number and it'll jump up that many numbers to the next value. And then it'll pick another amount and it will jump up randomly to another value. So if mine's starting at a different starting place from yours, then my sample numbers will be different from your sample numbers. So at this point I want you just to hit enter. Now once you've done that with whatever calculator you're using, you never have to do it again. You only do it when it's the first time you've ever done this. So at this point, we're going to talk about how is it that you actually get random numbers. Before we get started on that part, let's look at what your handout looks like. We want to take a simple random sample from this group. That doesn't mean I'm going to sit here and put my finger down on some of them, because it's hard not to cheat to make sure that I actually get my finger on a piece of paper. And then, maybe I like the looks of some pictures more than another. So I don't want to, I don't want to prejudice this in any way. So what I'm going to do is, first, I'm going to number the members of this population. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 15 members in my population. I want to randomly choose 4 of those people. And the way that I randomly choose 4 of those people is I go on my calculator to the math menu, but I don't use the first thing that pops up. I go over to the PRB, the probability menu. And I don't use the one at the top because that gives me a big long string of decimal numbers. And I'm not needing decimal numbers because I'm counting people. 1, 2, 3, 4, 5. So what I want is random integers. So I'm going to go down and choose number 5. And then what I have to give my calculator at this point is, what number do you want to start at and what number do you want to end at? Basically, my first person was person number 1. And my last person is person number 15. So I type in the numbers 1, comma, 15, and I close the parentheses. And once I've done that, I hit enter, and it says, okay, choose person number 1. So I'll circle person number 1. Did anybody else in here, when you did what I did it give you person number 1? Okay, so everybody else didn't get person number 1, but I did. Okay, circle whichever one that it told you to circle. And then hit enter again. So my second person is person number 6. So I look on my list, and I circle person number 6. And then you do that again. You just hit enter again. And mine says, now choose person number 12. So I'll circle person number 12. And then it says choose person 15. So I'll choose the last person. And now I have my sample of 1, 2, 3, 4 people out of the group of 15. Did anybody in here choose the same 4 people I did? Okay, somebody want to volunteer which ones you chose?
What happens if it gives you 2 of them? It's the
Same one? There's a repeat. That actually happened on the example here that's on the handout. This person that was doing this chose person number 4, then number 7, and then chose 4 again. So notice what they did was they kept hitting enter until they got 4 different people to circle. So you can't count person number 4 twice, because then you don't have 4 different people. Okay? Who'd you get?
5, 7, 13, and 15.
Okay, 5, 7, 13, and 15. So you have 1 in common with me. But that's it. Who did you get?
2, 10, 12, and 13.
Did anybody else get 2, 10, 12, and 13? The exact same.
I got 13, but I didn't get the rest of it.
Okay, and it kind of makes sense that some of us are going to have 1 of the same persons in our groups, Because we've got 15 people and there's close to 30 people in this room.
About 1, 3, 13, and 10. So
Yeah, 1, 3, 13, and 10 is a totally different group. You have one in common with me, one in common with her. Okay? So that's how you take a random sample. Now, a random sample is not too hard to take if you actually have access to your whole population and you can number them. Now, if I were talking about all the community colleges students this semester in Northeast, or in all of Tennessee, there's 14 community colleges. I could ask the registrar at all the different community colleges, how many students do you have? And they could tell me, and then I would add those all up, and I would choose one college to be college 1, and then I would just number all the students in sequence after that. And maybe I could eventually get a random sample of, let's say, 1,000 students. But it would take a lot of help from a lot of other people, and it would cost a lot of money to be sending that information back and forth. So random sampling is what we want to do, but realistically it's hard. With most populations, it's really hard, because you don't usually have access to your whole population. So the second best one might be the systematic sample. The systematic sample, we're going to use the group at the bottom of the page. And it gives you the directions there for doing it. Number the members of the population, randomly select one of the first K members, however you decide to increment your group, and then select every K, and this could be every 4th or every 5th or every 7th, however we wanted to do it. We would select every Kth member. So we have a population here, which once again, you have to have the whole population available to you. So I need to count how many are in the population. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 members in my population. Now, if I want to select a sample of size 4 from this population, 4 goes into 28 7 times. So I would use the increment of 7. And I would randomly generate a number 1 through 7 and choose from the first 7, and then automatically take every 7th one after that. But this time I actually want a sample of size 4. Okay? I want to choose a sample of size 4. It doesn't, if we choose every 4th member, that means that we're going to randomly select one of the first 4 members. So we hit the math button. And go over to PRB. And down to number 5. And tell it we want to select randomly a number between 1 and 4. And hit enter. So that means I'm going to choose from among the first 4 people. I chose person number 2. Now, if I specifically wanted exactly 4 members, then I can't use the increment of 4, but this says select every 4th. Well, if I do that, this is person 1, 2, 3, 4. That person will be in my sample. And then I go again. 1, 2, 3, 4, and that person will be in my sample. And then I go again. 1, 2, 3, 4, and that one's in my sample. Now, if I wanted a sample of 4, I didn't choose a big enough increment, because I've got my sample of 4, but because my population was so large, I've left out half of it. So if I wanted a sample of 4, I'm in trouble. Let's say I had wanted a sample of 7, though. Well, this would work fine, because I have 1, 2, 3, 4, and then go 1, 2, 3. I'm sorry, from there's 1, 2, 3, and this would be the 4th one. So I would keep going. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2 would cause me to go back and recount some people, so I don't want to do that. So actually what I've gotten now is a sample of 1, 2, 3, 4, 5, 6, 7. If I had actually wanted a sample of 4, then I should have chosen 7 as the increment. So if I randomly choose among the first 7, the only thing that changes is that last number. So I would start in this case at person number 3. And then I increment by 7, so that would be 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, I'd have to go back to the beginning, so I'm done. And in this case, I have 1, 2, 3, 4. So your increment is determined by how big a sample you want to actually take. Take your sample size, divide it into the population size. If you need to, round it to a whole number and let that be your increment. And that'll give you a sample from your population of the size that you want. But the idea here is that you understand that I'm very systematic. Once I've chosen that first member, then actually the rest of the sample's chosen. Because I'm going to take every 7th or every 4th member after that. Okay? Now, it's still random, because everybody has an equal chance of being the first person that I choose. I could actually choose randomly between 1 and 28 to choose the starting point, and then increment however I wanted to. So it is more random than what these other methods that we're going to talk about, but it's not a simple random sample, and it does still have the drawback that we'd have to have the whole population to be able to actually do this. So here's our first exercise. Describe how to take a simple random sample of 9 pieces of fruit. Include the calculator command that you use, and take the random sample and circle your selection. Okay, how many pieces of fruit do we have, first of all? Because our first thing is going to be count the fruit. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40 pieces of fruit. Okay? Now, if I want 9 pieces of fruit, 40 divided by 9 does not come out even. it comes out to be 4.4. So I'm going to have my increment be 4, because it'll round down to 4. So my increment's going to be 4. So my increment's going to be 4. I'm going to randomly choose a piece of fruit to start with. And since there's 40 pieces of fruit, I'm going to put in all 40 of them. Everybody gets a chance to be the first one. So fruit piece number 26 is going to be my first choice. So the first one I chose is the 26th piece of fruit, which happens to be a pineapple. And I went ahead and numbered all the rest of them. So now that I have chosen number 26 and I decided my increment is 4, then I start here and I count from there to the 4th piece of fruit after 26. 1, 2, 3, 4. So my next piece of fruit is 30, which is an apple.
If I have 37 and I count to 4, do I go back up to 1?
Yes. Yeah, and I'm going to have to do that too because I'm so far down in here. So then I've chosen this one and I go again, 1, 2, 3, 4. 1, 2, 3, 4. I got another apple. 1, 2, 3, 4. Now I got a banana. 1, 2, 3, 4. I have another apple now. Notice I went back to the beginning of my population. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. I already chose 26, so I'm done. How many pieces of fruit do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I actually wound up with 10. I rounded down to the 4. If I had rounded up to 5, I would have gotten probably the 9 that I wanted. So the downside to and that was supposed to be a simple random sample. I was doing systematic. I'm sorry. I was not doing simple random. I took a systematic. And the downside to systematic sampling is that you can't always get a certain size sample. You can get one more than you wanted or one less than you wanted, but you can't always get exactly the number you wanted. Now, if I had been doing random sampling, which was what I was supposed to be doing, then this is how I would have done it. Let's see. Get a highlighter. If I had been doing a random sample, then I go to math and over to PRB, my first step is the same. Random integer, and then 1 comma 40. Okay, the first one is number 35. I hit enter again and it says my next one is number 18. I hit enter again and it says number 24. I hit enter again and I have number 35, but I've already chosen 35, so I skip it over and keep going. Piece of fruit number 3. Hit enter again, it says number 17. Hit it again, it says number 23. So I've got 1, 2, 3, 4, 5, 6. I need 3 more. Number 19. Number 1. 17's already been chosen. Number 37. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9 pieces of fruit. Notice that the 2 samples didn't come out to be the same. There's nothing wrong with either one. It's just they were different sampling methods. This one that I highlighted in yellow was the simple random sample. The other one was a systematic sample. They contain different pieces of fruit. Talking about the simple random sample, it says find the percentage of pineapples in your sample. Well, my sample is 9. How many pineapples? 1, 2, 3, 4, 5. 5 out of the 9 were pineapples. So that's 0.555. And it says what percentage, so I need to move that decimal 2 places to the right. And that's 55.5% or 55.6% if you round correctly. Really should be 0.6%. Okay? So if it says percentage, do a percentage. If it says proportion, you can give the fraction. If we're going to do anything with it, like, you know, okay, suppose we have another group of fruit that has 50 pieces in it, how many pineapples would we expect? Well, we would multiply, and that means we would have to take it back to the decimal, 0.555. Okay? So we've seen how to do a systematic and a simple random sample here. Yes, ma'am?
So for the systematic, are we supposed to find the percent of just 9, even though we circled 10?
In the case of the systematic, we would have to use the 10 that we chose.
Okay.
So if we did that, we have 10 pieces of fruit, and the 10 pieces, the 10 pineapples that have a red circle are, I'm sorry, have a purple circle, would be one, 2, we actually only got 2 out of 10, which would be 20% in our systematic sample. So you see that they're very different. Okay? Now I want you to think about this process. You have a bottle filler that the heads on it rotate. And as it rotates, it's constantly filling up each one of these nozzles. But as it rotates, That nozzle that's down is the one that fills up the next bottle. Now this filler is actually defective, okay? We don't know that, but it's defective. As you can see from what we were looking at here on the line, every fourth bottle, which is when you have nozzle number 4, it only fills up halfway. The others are doing it correctly. There's 5 bottles, so this is nozzle number 1, 2, 3, 4. Nozzle number 5 is a problem. I'm sorry, nozzle number 4 is a problem. This will be bottle number 1. So every fourth bottle is going to come up half empty. We need to get a representative sample of what that line is producing. Would a systematic sample be a good representative sample? I see a couple people shaking their heads. Why not? There's 2 things that could happen if I take a systematic sample. Let's suppose I randomly started with bottle number 7 and I counted every 5th bottle. 1, 2, 3, 4, 5, 6, 7, and so forth. What's going to happen if I choose this is the first one and then every 5th one after that? Am I likely to ever hit a half-filled bottle? No. Probably not going to hit one at all. What if my first bottle chosen was this one? And I go 1, 2, 3, 4, 5, and then what's going to happen next is full, 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 half empty. And every bottle in my sample is going to be half empty. What do I think's wrong if that's what I get? Am I going to recognize what the real problem is? No, I'm just going to know that it's not. I'm going to think it's filling all the bottles half full. Probably going to shut down the line, make them tear the machine apart and redo it. But if I take every 5th and I'm starting with a full bottle, what am I going to think then? It's working just fine. No problem. Let it keep going. So then the company ships the bottles out, they put them in the machines, or they put them in the coolers in the stores, and the customers come and say, oh, excuse me, I'm not paying $2 for this. It's only half a bottle. Okay? So systematic sampling sounds good because it's easy to do, but it isn't necessarily the best, especially if you have some kind of a pattern going on in the population you're sampling. Think about another example. Suppose I had all of the student records at Northeast State this semester, and I decided to randomly choose a beginning student and go through that filing cabinet and choose every 100th record. How many people are in those filing cabinets whose last name begins with S? Smith, Sutherland, Sampson, Sammons, St. Laurent. All kinds of last names begin with S. How many people do you suppose are in that filing cabinet whose last name begins with a Z? Or an X? Or even a Q? Compared to the S's, or the A's, or the T's. What's going to be wrong with a systematic sample? Am I likely to choose anybody whose last name starts with a Z? Probably not. I might skip right over all the people whose last names start with Q. Might skip right over all the people who have a last name that starts with an X. It's not saying they're not there, but they're not going to get chosen because I'm likely to skip over them because those records are in alphabetical order. So there are limitations to systematic sampling, and that's my point. You have to realize that having the system means the system can actually work against you if you're not careful. Now we're going to take an actual stratified sample which is not what we've done before. Stratified means that you divide your population into logical groups. If I'm sampling aircraft, a logical grouping would be the airports that those aircraft fly out of. So my 4 groups in this case are Russet City, Jasonville Airport, Chasentown Airport, and Nelsonville Airport. Okay, those are my 4 groups. I'm going to select some members from each group. Some members goes along with the idea of a stratified sample. In order to randomly choose those members, I need to number the different groups. So Russet City is going to be a group by itself. There's only 8 of them. Since I want a sample of 4, I want 1 aircraft from Russet City, 1 from Jasonville, 1 from Chasentown, and 1 from Nelsonville. So for this one, I'm going to choose a sample by going rand int 1, comma. Now this says 10 because somehow on the PowerPoint it was 10. But we see that we only have 8 here. So we're going to do rand int 1, comma 8. Okay, and we're actually going to take this one. So you take a sample and I'm going to take a sample. Math, PRB, go down to number 5, start at aircraft number 1 and go to aircraft number 8 because that's how many we have. And it says that I'm going to include aircraft number 4. Anybody else in here choose aircraft number 4 from that group? Probably some of you. Okay, now my next group, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually I think this screen went with this group and this screen went with this group. I think I got them mixed up. So for this one we're going to go rand int 1, comma 10. So I'm going to choose aircraft number 6. And then I'm going to move on to the next airport. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'll choose number 5 from this group. And then the last group, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 in that group. And I'll choose number 8. So I have my sample of 4. If I had wanted a sample of 8, I would have chosen 2 from each airport. Okay? I might have also chosen to take 2 from this one because it's larger than the others. And let's see. Maybe 2 from that one because those are larger. And then again, maybe not. It just depends. You can choose a different number from each group, but the idea is you choose some from every single group. You don't have to choose the same number from every group, but you do take some from every group. Okay? This is not a random sample because it doesn't satisfy probability rules. Does every single aircraft here among those 4 airports have an equal chance of being chosen? Does a plane that comes out of Russet City or a helicopter have an equal chance of being chosen to be on our sample as one that comes out of Chasentown Airport? Why not? That's right. The airports have different numbers of aircraft. So actually the Russet City Airport, their aircraft have a less chance. They have a 1 in 8 chance, or a 1/8 chance of being selected for the sample. Whereas Chasentown, they have a 1/11th chance, which is a lot less. So Russet City has an advantage. Okay? Does that make sense? Does anybody have any questions? Okay. Same set of airports. This time, we're going to take a cluster sample. Cluster samples means you number the groups, not the aircraft. So Russet City is group 1, Jasonville is group 2, Chasentown is group 3, and Nelsonville is group 4. And when we take a cluster sample, we're going to randomly choose 2 of the airports. That means we're going to have a big sample. Okay? We're going to randomly choose 2 of the airports. Now, the one that's shown up here is that they chose airport number 3 and airport number 2. If I do it, I shouldn't get the same 2 airports, although I might. There's only so many pairs you can get. Actually, I did. I got 2 and then 3 rather than 3 and then 2. You choose 2 airports and tell me which 2 you chose. No, airports, not planes, airports. Because remember, you're picking groups on this one.
I got 1 and 4.
Okay, the clusters are your airports, so you've got different groups. Okay, you got which ones? 1 and 4. So you got the exact opposite of what I got. You got this one and this one. I got this one and this one. Who else got a different group? What'd you get?
1.
Okay, so this one and this one. 2 drawbacks here. Do they all have an equal chance of being selected? Actually, yeah. Every aircraft has the same chance of being selected because the groups are 1 through 4, so every airport has a 1 in 4 chance, which means its planes have a 1 in 4 chance. So that's equal probability. The drawback, can I say what size sample that I want to take? No. Because I might have a sample of 21, I might have a sample of 20, I might have one of 19, just depending on which 2 airports I chose. Okay? So the key words to remember here: systematic, think about a file cabinet. Every X is chosen, and you pick out what X is going to be. But for cluster and stratified, Your population has to be put in groups. And in stratified, you take sum of each group. Cluster, you take all of some groups. You have to think about which one of those words came first. Okay? What we're going to do is another exercise. We're going to take a stratified sample of these trout. We want a stratified sample of 3 trout from each waterway. So our groups or our clusters are Clear Creek, Tosha River, Shinbone River, Lucky River, and Austin Creek. And from each one of those waterways, we want to choose 3 fish. I want you to work with whoever's next to you and figure out how to take those 3. And then you're going to find the mean length of the trout in your sample, which means since you're taking 3 from each group, that's 3, 6, 9, 12. You're going to have 15 fish. You're going to need to write down the lengths of all 15 of the fish, and I'll show you how to calculate the mean. So just somewhere over to the side, list the weights of the 15 fish you chose. Okay? Take a few minutes and do that. In Showbie, there is a folder, and it has the wrong due date on it.
When is it due?
It's due tonight. The first file is a Word file. You want to download that Word file and open it with Microsoft Word. When you do that, and I think this actually might be a duplicated folder, so I'm going to go look and see if I can delete the one that we're not using. So this file, you want to download the Word file, and the Word file looks like this. The answers you need to do before you leave class, because I doubt that any of you are running around with tape measures, but I am. You can answer the rest of these from home, but when you come down to number 6, number 7, and number 8, you can do number 8 by yourself. You can measure your own foot. A lot of people are squeamish about measuring other people's feet or having their feet measured, so you can measure your own foot. I have little tape measures, and surely nobody has a foot longer than that. Okay, so this is what you measure your foot with. The other thing is you are going to measure your height. Don't tell me what you think it is. Get up here and measure it. You're going to measure your height and your arm span. And to do questions 6 and 7, I would suggest that you get a partner to come up here and help you. I've got 3 tape measures that will measure height and arm span at the same time. So you want to go ahead and record those in inches, and you can actually answer these right here. lost something. So you can go ahead and type your answers in. Just be sure that you save this as an Adobe file when you're finished. But record all of this information. Notice that it says, what is your U.S. shoe size? So I don't want to know the one that's in centimeters. I want to know your U.S. shoe size. 7.5, 8, 8.5, whatever it is. In what month were you born? How many siblings do you have? What's your favorite day of the week? What social media site do you use the most? What cell phone company do you use? How many texts per week? Do not give me a range. Don't say between 500 and 600. Tell me it's 593 if that's what you want, or 600. But one single number. And then number 16, think of somebody famous. I didn't say it had to be a singer. I didn't say it had to be an artist. I didn't say who it had to be. Just somebody that's famous for whatever reason. And Google their name and find out what year they were born in. Give me their name and the year of their birth. We're going to use that for something before we take our first exam. So I'm going to give you the rest of class time to collect the information you need, especially the information you need with my tape measures. Arm span, incidentally, is from fingertip to fingertip, holding your arm straight out. Has to be straight out. The best way to get any of this is to come up here, and I'm going to turn the lights back on and put the screen up. The best way to do it is actually come up here and stand at the whiteboard with your partner, have them mark at the tips of your fingers, and then the two of you measure from one mark to the other. So let's go ahead and get that done. And that is a quiz that everybody ought to make a good grade on. So there's a marker to get you started. We'll turn the lights off, the projector. I have some extra markers, so you can work more than one person at a time up here. Probably get as many as 3 or 4. Be sure to erase your marks so that the next person won't get them confused.